Alright guys, we're going to be looking at vectors today. It's the next topic, and we'll go over this again on Thursday when I get back. So basically, we've talked about vectors before as being things that have a magnitude and a direction. So an example of a vector would be maybe a velocity vector that we're launching something at. So we could have it at an angle above the horizontal, maybe 30 degrees. And we could also have a velocity being, say, 10 meters per second. So a direction and an angle, or a direction and a magnitude, are the two things that we're focusing on here. So for today, the most important part is being able to find the x and y velocities, or being able to find the resultant magnitude if given the x and y velocities. So let's say, for example, that we have a vector like this with a magnitude of 25 at an angle of 30. And I want to find the x velocity and the y velocity. So the way we do this is we use right triangle trig. So if we could label the sides of this triangle, we would have, if our angle is down here where 30 is, we have the adjacent side, we have the opposite side, and we have the hypotenuse. So if we were to set up an angle like this, sine of 30 is going to be the opposite over the hypotenuse. So sine would be Vy divided by 25. And then rearranging this, multiplying both sides by 25, then Vy equals 25 times sine of 30. And we could type this in. Let me grab my calculator out here. We take 25 times sine of 30. You get 12.5. So that would be my x component, or my y component, sorry. Now, if we set up cosine of 30, that would be the adjacent, which is x, over the hypotenuse, which is 25. So then Vx would equal 25 times cosine of 30. Which is about 21.65. So basically, this triangle would look like this. We have measurements of 21.65 on the x and 12.5 on the y. So those are my x and y components. So taking a step back now, that's kind of an example of doing this straight through. We need to remember what our ratios are. So we have sine is opposite over hypotenuse. We need to remember this from analytic geometry, probably last year or year before. Cosine is adjacent over hypotenuse. And then we won't use this a whole lot, but tangent is opposite over adjacent. All right, and I'm sure you guys have heard of the SOHCAHTOA, this little acronym to help you guys remember. If you know how to spell SOHCAHTOA, then you know all of your sine, cosine, and tangent, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's one way you can remember this. So now for formulas in this, if we have a triangle that we make from a vector, we have a vector at some angle, we have the resultant. The resultant is the hypotenuse, or the magnitude. Resultant and magnitude, same thing. Usually that means the hypotenuse. And then we have our x and our y. And if we let this be an angle theta, so some unknown, we have Vx, we have Vy. Our equations will look like this. Vx will be the hypotenuse times cosine of theta. Vy will be the hypotenuse times sine of theta. Alright, and now again, this is the hypotenuse. That vertical looks like an absolute value bar. All that is the hypotenuse, just whatever this value is over here. Alright, and now if I'm given two legs of a right triangle, so let's see here. If I gave you that this is 3 and this is 4 perhaps, and I wanted you to find out what the hypotenuse is, we use the Pythagorean theorem. So remember, Pythagorean theorem is a squared plus b squared equals c squared. So I'll take 3 squared plus 4 squared equals c squared. We add these up. This ends up being 25 equals c squared, and c is 5. So don't forget about the Pythagorean theorem when dealing with our right triangle trig and vectors.